Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective, and we are embarking on an exciting journey into the world of data analytics with Azure Databricks. Born from the brilliant collaboration between Databricks and Microsoft, Azure Databricks solves complex data mysteries, leveraging the power of supercharged Apache Spark and integration with Azure services to enhance security, performance, and scalability. In this mystery, we'll uncover how Azure Databricks fosters a collaborative environment for data analysts, supporting a variety of programming languages, and offering robust tools for data ingestion, manipulation, and analytics. Whether it's creating workspaces, managing Spark clusters, or creating lakehouses and warehouses for reliable data management, Azure Databricks equips us with the tools to solve the most complex data mysteries. Let's dive in and solve the case of the Databricks dilemma. Azure Databricks operates with a dual-plane architecture, where the control plane includes back-end services managed by Databricks, and the compute or data plane provides the resources to process and store data and is managed by Azure and your organization. In the serverless compute plane, Azure Databricks resources operate within a secure network boundary. This setup ensures that different customers' workspaces remain isolated, preventing any data leaks or breaches. The classic compute plane, however, runs within each customer's Azure subscription, offering a more traditional approach to data processing with its own set of security measures and regional support. The workspace storage account is the vault where all the clues and evidence are stored. It contains workspace system data like notebook revisions and Spark logs, and the Databricks file system, DBFS for short, designed to hold valuable local workspace data and objects. If Unity Catalog is enabled, the workspace storage account includes a shareable workspace catalog, allowing users to create and manage assets seamlessly. This setup ensures that all data is securely stored and easily accessible for analysis and investigation. If you're setting up a new Databricks workspace, then you're in luck. Unity Catalog is good to go. If not, there are migration options. Now that we know a little about what Databricks is, let's look at how to create a workspace. Creating an Azure Databricks workspace is the first step in embarking on your data detective journey. Whether you use the Azure portal, ARM or Bicep templates, PowerShell commandlets, or the Azure CLI, you can select from standard, premium, or trial pricing tiers to match your investigative needs. Once your workspace is set up, the Azure Databricks portal offers a web-based interface to manage resources like Spark clusters and run notebooks and queries, enabling you to dive deep into your data mysteries. Once your workspace has successfully deployed, you can access the web-based portal via the Azure portal through a direct launch, or you can log in from any browser using the provided URL path. This web-based portal will be your hub for detecting and collaborating. The greatest detectives work with a team to solve mysteries, and Azure Databricks provides a collaborative workspace, catering to a variety of workloads, each tailored to contribute to solving different types of data mysteries. For data scientists and engineers, the platform provides an integrated environment with Apache Spark for processing big data in a lakehouse, supporting Python, R, Scala, and SQL for data exploration and pipeline development. For machine learning sleuths, Azure Databricks offers optimized tools for building, training, and deploying machine learning models at scale, complete with MLflow for lifecycle management, and support for frameworks like TensorFlow and PyTorch. Data analysts can take advantage of the SQL workload, featuring a SQL editor and dashboard tools to quickly analyze and report on large data sets. Now let's discover the clues to other key concepts in Databricks. Azure Databricks concepts such as workspaces, notebooks, clusters, and jobs are essential tools in your analytics detective kit. We've covered workspaces, so let's look at the other tools. Notebooks offer interactive documents for running code, visualizing data, and writing narrative text. Clusters act as the computational engine, scaling to meet your resource needs. The Databricks runtime, built into Databricks clusters, enhances your investigative capabilities with proprietary performance-optimized versions of Apache Spark. Say that 5 times fast. We'll uncover more clues to clusters later on in the course. An Azure storage account serves as a data lake to implement Delta Lake, which is an open source storage layer that enhances data lakes by adding reliability and performance features. Stay tuned for more leads in Delta Lake later in the course. For SQL detectives, Databricks SQL enables quick, ad hoc queries and report creation directly on big data, complete with a SQL editor and dashboards. And yes, my fellow detectives, we will look into this case with more detail later in the course. At this point, you can imagine the vast amount of assets that we're going to need to organize and govern in our Databricks environment. So what can we leverage to help with this? Glad you asked. Unity Catalog provides centralized access control, auditing, lineage, and data discovery capabilities across Azure Databricks workspaces. The Unity Catalog object model is structured like a well-organized case file, with a 3-level hierarchy of managed storage: catalogs, schemas, and tables. Catalogs are at the top level container, often mirroring organizational units or project scopes. Schemas within catalogs are essentially database objects that contain tables, views, volumes, and AI models, organizing data into logical categories. Tables and volumes can be managed or external, with managed tables being fully governed by Unity Catalog, ensuring data integrity and security. This hierarchical structure helps you keep your data assets neatly organized and easily accessible. Working with database objects in Unity Catalog is as intuitive as following a detective's lead. Using familiar ANSI SQL syntax, you can create, manage, and secure database objects. The Catalog Explorer user interface provides a user-friendly interface for managing these objects, making it easy to grant and revoke access permissions. This ensures that only authorized personnel can access sensitive data, maintaining the integrity of your data governance policies. Metadata is the data that describes data and is the foundation of data governance. Data governance tools like Unity Catalog and Microsoft Purview play a crucial role in managing data securely and effectively. Unity Catalog offers a governance solution for data assets, providing a centralized metastore and fine-grained access controls within the Databricks environment. With the Lakehouse Federation feature, you can run queries across multiple data sources without needing to migrate all that data to a single location. Delta Sharing is a secure data sharing platform that lets you share data and AI assets with users outside your organization, whether or not those users use Databricks. Microsoft Purview enhances data governance with features like data discovery, classification, lineage, and access policies, all ensuring compliance and optimizing data management strategies for enterprise data assets inside and outside of Databricks. Both Purview and Unity Catalog together is like a 1-2 punch for data governance. Looks like I need to work on that. Now it's time to put our knowledge to practice. I'd like to introduce you to the DetectoLab 5000, my Surface laptop. Remember that Azure Databricks is a web-based platform, so you don't need a 32 gigabit RAM, GPU accelerated, 1 terabyte SSD, 8-core processor system to solve mysteries in Azure Databricks. I can also work from just about anywhere, although they won't let me leave until I finish this course, so just trust me on that. Onward! All right, welcome detectives to the DetectoLab 5000. Now we're going to create a Databricks workspace and go through some of the components of it so that you have a better understanding, create a cluster, do some basic things to get our environment set up for the rest of the things that we're going to be doing in here from an analytics perspective and engineering perspective. So I'm here in the Azure portal, and what I'm going to do is I'm just going to search for Databricks and just click on Azure Databricks. And then I'm going to create an Azure Databricks service. So you can see that it lists a workspace. So I'm going to be creating a single workspace. Now, when you go out into the real world, most likely you'll be deploying or will have available several workspaces, which is why this managed resource group comes into play. But first we need to pick a resource group. So you do need a valid subscription, you do need a resource group, and you need to provide it a workspace name. So I'm just going to call it this. Now there's character limitations and types of characters that you can use that won't apply, but the portal does a pretty good job of guiding this. If you're going to do this through, if you're going to do deployments through biceps or CLI commands or things like that, infrastructure as code, then you're going to have to be on point with the character choice that you pick and how many characters that you choose, because it could always kick back an error saying that you got too many characters or this character isn't valid, and then you got to restart the whole process over again. I'm going to go with the region that it provided me, the UK South. Now I'm in the US. I think this is a great point to provide you that even though I'm working within the US, you'll notice that there's not too much involved in latency, but there will be a little bit of latency involved when you select a region and deploy it. Now, the reason why you want to select a region is, or what region to select is, well, where your users are going to be, right? Or where the data resides. Obviously, there's regulatory requirements that may require the data to stay in the same region as what it was generated in. You would have to deploy a workspace in that area and work with it there. But the workspace is web-based, so we can work with that data from wherever we want. The pricing tier. Now, if you want to do the online content, so through the course, the online course, there is the ability to do lab exercises. And, when you're utilizing compute and storage and things of that nature, those all have costs associated with it. So a trial will give you 14 days free access to a single node cluster. No premium features, but at least you get through most of the labs that are associated with this particular course. And then there's standard and premium. We're going to take premium because we're going to be making, we're going to be utilizing the SQL Hub to create warehouses and do SQL queries and create dashboards. And that's only available in the premium tier. You could give a name for your managed resource group name. If you don't, then it's going to provide a generic one or a default one. Then you can go from there. Now, this is a web-based platform, and Azure does have a pretty secure way that everybody accesses the web, even if it's deployed publicly. But if you want the workspace deployed in a private network, you can certainly have that option here. I'm not going to pick it here, but you can do that. If you want your cluster connectivity to have no public IP addresses, or if you want your workspace to be in your own virtual network, you can choose to do that. From an encryption perspective, data is always encrypted at rest, and usually when you're dealing with data in transit, it's protected by the TLS protocol. Here, all we're doing is selecting whether or not we want Azure to manage the key rotation for the encryption, or if we as an organization want to manage that key rotation. If we do, then there would be some options we would want to select here in order to do that. And then there's some additional security monitoring features that you can enable and apply tags to them. Tags allow us to, for billing purposes or management purposes, really get to a granular level of what the purpose is of this workspace, where it's at, and things of that nature, so that somebody can come in and track exactly what costs are associated with this particular workspace. I'm not going to do any of those additional stuff. I'm just going to go with what I got with the required. Everything will be publicly available at this point, so you'll want to consider those security considerations when you're deploying that. I'm going to, through the magic of video, I'm going to let the Detecto Lab spin this sucker up, and then we'll rejoin here in a second. All right, looks like our deployment's complete. It took about 3 minutes to do this from my side. Just know it may take a little bit longer depending on the settings that you placed in the deployment options. But it took about 3 to 4 minutes for this to happen. So I'm going to go to the resource. Actually, I'm going to back up. This is the actual workspace page in the portal. So I'm going to back up and actually go into my resource groups because I want to point something out here. So I place the workspace under the Databricks resource group. So you can see that the workspace is located here. This is where I can actually access the user interface for Databricks. When I go back into my resource groups, you can also see, if you remember, I called out that managed resource group, right? So this is the name it's going to give you. It's going to give you some randomized name based on whether or not you entered any managed resource group value in here. But this is that managed resource group. And you can see that it was deployed in the UK South. The reason I want to point this out is because these are where the resources are actually located that you're going to be utilizing for your Databricks workspace. So the workspace is controlled by Databricks, right? So the compute and the storage options are all managed by Azure. So that's why this managed resource group is created. All the Azure resources get placed in here so they can be shared across different workspaces. This includes a managed identity, which is attached to your Databricks environment, a storage account. Actually, the Databricks file system, or your Unity catalog in this case, is actually an Azure storage account under the hood. You can also see this Unity catalog access connector. So I mentioned Unity catalog. This access connector allows us to connect our Databricks workspace to managed identities. This makes integration with other Azure services super secure and super easy. So typically another Azure resource or service can take on a managed identity, or we apply a managed identity to that service. This way we're not hard coding connection key values or doing things like that. If you use the managed identity, that's the most secure way of connecting to other Azure resources. So great resource to have within this. And then you can also see that there's a virtual network and a security group applied. And these are where our clusters are going to get deployed to into that virtual network. So these resources are necessary for us to work across several workspaces, right? Because we may have clusters that are shared against several workspaces. The storage, we may be sharing assets in that same storage account. So this makes it available for us to access from several different workspaces all over the globe. And that's why this managed resource group is such a vital part of the Databricks environment. This is where we're allowed to create and deploy the resources. So it's definitely worthwhile to have. Now, let's go back into the actual workspace itself. And you can see here that there's certain settings in here, like I can control access through rollback or role-based access controls. I can assign role assignments. I can apply tags after the fact. There's some settings that you may want to apply to this involving encryption and security and things of that nature. And if this turns out to be a single workspace that fits the bill, meaning that it gives you the approval of, or the gold standard, so to speak, for all of the workspaces you want to deploy, you can actually export this template out and then use this template as to deploy 100 of the same type of workspace. So this is where we're getting into infrastructure as code, but this is where you can grab that information. By the way, most Azure resources have the ability to export that out. Information about, so documentation, everything is available here. There's some information about the assets that are in here, but I can launch the workspace a couple different ways from here. So from the portal, I can launch it using this button. And since I'm already logged into the portal, this doesn't require me to have to use like multi-factor authentication to log in. If I use the URL, now remember, this is a web-based platform, so anybody from anywhere can work in Databricks. They would be using this URL to access it. They obviously wouldn't go into Azure to access the workspace. They would just open up a browser and then you can favorite this or bookmark it and then come back to it time and time again. But if you use it this way, you will have to, sign in using your credentials if you have it. Now I'm still logging into the portal and I'm logged in that way, so I won't have to do it here, but typically you'll have to pick out what workspace you're going to be working with and so on and so forth. Couple caveats. I don't like white backgrounds, so I use dark themed, dark mode themed workspaces. So if you deploy the Databricks workspace, just know that it's probably going to look a little different than this because I use dark mode. So dark mode applies this darker background to it, changes the contrast colors on the font. So your experience may be a little different when you launch it, but everything's still in the same place. This is just more of it being easier on my eyes. All right, so let's go through all these different objects here that are associated with this particular course. We may not cover too much we're not going to cover anything with the machine learning. I'll just touch on it a little bit. But over here on the left-hand blade, and by the way, you can minimize this too so you can get the full screen experience by hitting that hamburger icon up at the top. But you can see when I navigate into each area, this is my workspace. So these are the assets that are located within my workspace. You can see that if I can connect to GitHub repositories, I can put assets in the shared folder. Or I can go into my own stuff, right? So anybody that has access into this particular workspace will have their own user location where they can place their assets if they want to as well. So these are workspace assets like notebooks, things like that. You can also track your recent items, and then you can view your catalog. So this has to do with the Unity catalog, with that Databricks file system, things of that nature. We'll talk about workflows a little bit later on, but these are essentially pipelines. And then clusters. Before we start creating a cluster, which we will do here, just going through some of the other workspace hubs. So you see that we have a SQL hub here. That comes with the SQL area editor, which is a SQL endpoint querying. So this is just an application that Databricks created that allows us to query data in our warehouses. You can also save queries that are executed or saved here. You can also create visual dashboards, any alerts that you want to place on your dashboards. And then I can view my query histories and also set up SQL warehouses, which we'll cover later on in another module. Data engineering. So, when we're creating job runs or doing data ingestion, it has different connectors for us to connect to different data sources if we need to. And we'll also talk about Delta Live tables in a separate module of the course. But these things are located under that data engineering hub. And then finally, machine learning. These are for data scientists, perhaps, that do model training. So model training may take several runs in a single experiment, so we can set up experiments and subsequent runs here, feature stores, and then any models that we train that we want to register, those go into this model registry too. There may also be some, partner, Microsoft partners, Databricks partners. They create assets and workflows and things of that nature that you can either purchase or get for free through certain hubs. Same thing with the marketplace. So those are those options there. Third-party services that have created certain workflows or processes that might apply to what you're doing. All right. Also, the settings can be changed up through here. So there is a settings tab. And there's work. So if you're a workspace admin, then you would have access to some of these other these workspace features in here. Under the user profile, you would have some other options here. We're not going to get too much into this, but there are settings that may apply to what you would want to change to make your experience a little bit better. Or if you're the admin, make it easier for your users. All right, so we're going to create a compute right now. This is essential, right? We know we're using a storage account, essentially is the backbone of the storage, but we also need processing power. So we're going to create a compute. Now, there's different types of compute. You can see that all-purpose computes can be used for several different purposes. If we want to create specific computes for jobs, which are part of workflows, we can do those. We can create SQL warehouse-specific computes. You can create pools of computes. And then you can apply policies, create policies for those. And there's different types of policies that can be created by the admins that restrict access or do certain other things. We're just going to create an all-purpose one for this and just create it. Here you can change the name. So I'm just going to call this DD cluster. Hopefully that naming convention works. So here's policies, right? So these are default policies that are created by Databricks. Your admins can create other ones. I'm just going to use an unrestricted one, but there's other options that you may want to use. Also note that you can create single node clusters. You can create multi-node clusters. What's the difference? Well, a cluster in Databricks, so there's the driver node and then there's the worker nodes, right? The driver is kind of like the manager, and the worker nodes are the workers and the manager says, well, we need 2 workers to perform this work, so it'll deploy 2 worker nodes. If you select a single node, essentially what you could see here is that we have a worker type and a driver type, right? So if I set this to single node, you see that we get rid of all that. The driver node essentially serves as the worker node. So it's kind of just like having a single workstation that's performing all the work. This is what you can do in your trial, by the way, but you can't typically select a multi-node cluster. We are, and we're going to give it access to me, obviously. The next thing you need to determine is what runtime you're going to want to use. If you ever see the LTS designation, that means long-term service. That means that for the foreseeable future, Databricks is going to maintain and support this runtime in the long term. If you don't see it, then most likely this version might go away. You can see some of these versions already have all the other intermediary versions eliminated from them. Usually there's going to be one stable version of it. So typically the long-term service one is the best ones to go with, but it may depend on what you're planning to do with the compute. So we're just going to stick with that. Also, you can see that there's machine learning versions of this. So, and the difference is that the runtime includes some machine learning packages like Spark ML and GraphX packages that allow you to do some neural network training or machine learning if that's what you want to do. You can see that there's also GPU enabled clusters here for those deep learning models. So those are available there as well. Photon acceleration. So this is based on the SQL package, and it improves the processing. I am going to go with the standard worker node that they're applying, and I'm going to go with the minimum workers and max workers. So when you set a minimum number, just know that this is going to be as soon as you attach a session, there's going to be 2 worker nodes that are going to be readily available to go. Now, if we submit a job and it requires more processing power based on based on the optimization that it runs through the driver node, it may deploy more worker nodes, but we set a max number. So don't go over 8 in this case, but always have 2 readily available to go. I might want to select a different driver node than a worker node because maybe I want a more memory optimized driver node. You can see that auto scaling is enabled on this. You could disable it. This just means that when it determines the work, it's going to go from 2 to 8 on its own. You can also see that there is a termination policy set for this. I'm going to set that for 30 minutes, but essentially what this means is that once you attach a cluster to a session, the session starts. If you're not doing anything in the notebook, or if the compute isn't performing any operations or is idle for 30 minutes or longer in this case, or 30 minutes, it will end the session and spin down the clusters. You can apply tags to these, again, for costing purposes or tracking purposes or auditing purposes, and then you hit create, and then this will start going. Some things to note afterwards is that once you have this cluster being created, You can install libraries on these. By the way, when you're setting these up in the advanced options, if you want to run initialization scripts on these as well, so you can run bash commands or some other things before you actually execute this cluster. So perfect example of that, if I want to deploy this in my own network and I wanted more control over this, I can get insight into what the IP addresses are for the worker nodes. I can get visibility into the deployment options for each one of these, and do some other things with initialization scripts like install libraries and other things on it, or add connectors. But typically you would add libraries through here, and you can monitor through the UI as well. We're, again, through the magic of video, we're going to let this cluster deploy. It takes 5 to 10 minutes for these to execute. So once this has been created, then we'll go ahead and bring in some notebooks and show you how that looks. All right. Our little green dot here has just told us that our cluster is ready to go. So it's on and running right now. When you see it in green, that means it's running. That means that 30 minutes from now, if I'm not doing anything, that'll turn red, meaning that it will terminate. I can also like manually terminate the cluster if I wanted to. We're not going to do that, obviously, but it's possible. Now, what I want to do is I'm going to load a couple things in here. And these are going to be used in additional Detecto labs that we're going to perform later on. But I obviously need the notebooks in order to do this. So I'm going to load up a couple different ways and show you how easy it is to import objects in here. Now, the default file extension for notebooks in Databricks is a DBC, or a Databricks archive file, or a DBC file. But it accepts or can take in several different types. So I'm going to go into my users. And what I'm going to do here is I'm going to right click on here, and then I'm going to import. Right now, there's different ways that I can import these notebooks. I could do it by a file. So if I already have existing files that I want to utilize, I could do that. But let's say I see a cool publicly available repo on GitHub that has a IPYMB or a .py file or some other type of extension that I want to bring into Databricks. You can actually go to a URL and include the file, the path for that particular file, if it's available that way, and if it's available for you to download or import and then use it that way. I have a couple of these that I'm going to bring in, so I'm going to show you a couple of these. I'm going to bring them in one at a time. So let's go down here and downloads. We're going to do this one. Now, this is a IPYMB, which is a Jupyter source file, or a Python notebook. IPYMB is the interactive Python notebook format. If you've ever worked with Jupyter notebooks, then you know what I'm talking about. But we're going to bring that in, and then I can bring in another one. So I'm also going to bring in this. Now, this is a .py file, so this is a Python file. But it will recognize a Python file, a .py extension. But now I have my notebooks in here. When I have these in, then I can open them up just by clicking on it. Since this is my personal, in my user file, then I don't have to worry about somebody else being able to access it. Just wanted to show you a few options. So what we've done in here is we've created a Databricks workspace. We went through the workspace components and took a look at clusters and notebooks and the different assets that we have. And when we come back back into this environment, we'll explore a little bit deeper, get into some of these notebooks, and solve some mysteries. Case closed. From creating collaborative workspaces and leveraging the power of proprietary Apache Spark, to managing comprehensive data governance with Unity Catalog, Azure Databricks truly empowers us to solve the most complex data mysteries. Whether you're a data scientist, engineer, or analyst, the seamless integration with Azure services, support for multiple programming languages, and robust machine learning capabilities make this platform indispensable. So buckle up and get ready to turn those data clues into actionable insights. And remember, in the world of data, there's no mystery too big when you've got Azure Databricks on your team. Just think of it as your very own Sherlock Holmes, but with more smarts and less pipe smoke. Thanks for joining.